And so we are continuing very briefly with some more naming examples of the alkenes. And here I've got one on the screen. And remember, an alkene is where we've got at least one double bond. So let's see, we're going to number this baby over here. Right, so we number it closest to the double bond, which is going to go 1, 2, 3, 4. And we find the longest chain as well. So 1, 2, 3, 4. Well, it doesn't really matter. I can do that. I can do this. Or, I can do that. Or I can even do this, because I still get 4 carbons. I'm still numbering closest to the double bond. Anyway, so we're just going to go across because that's quite easy. So it's 1, 2, 3, and 4. And then this thing over here, that's going to be something that is our branch. Now, branch that contains only one carbon atom, that is a methyl branch. Right. Now let's get the name out of the way. What is this name going to be? Well, the name over here is going to be 1, 2, 3, 4. 4 carbons is what? Bute. Refer to your summary sheet. And then there's a double bond over there, which is ENE. And we also got to tell us, where is that double bond? Well, it's on this first carbon. So, bute 1-ene. There we go. Bute 1-ene. Right. But we're not done. We've only named the main chain. We need to actually name this branch, this side chain over here. Well, it's a methyl branch. We already know that. So we can just say, well, it's methyl. Right. Methyl bute 1-ene. But where is that? That's on the third carbon. So 3-methyl bute 1-ene. That's the name over there. Okay. And so the question doesn't ask us for the condensed structural formula, but I'm going to write it over here. The condensed structural is just CH2CH. Right. And then there's CH3 as a side chain, which we put in a bracket like that. And that continues CH3. And there we go. CH2, CH3 in a bracket, which indicates the side chain over there. That's the branch, right? In fact, I'll just point over there. Right. And then there's CH3. Okay, so let's see what's in the next one. The next one over here, we've got naming the alkenes. Give the IUPAC name, and remember we said that's the International Union for Pure and Applied Chemistry name for the systematic name for the following alkenes. So here we go, C5H10. Well, that conforms to the general formula. Remember, it's CnH2n. If I put in 5, I get out 10, and clearly that is an alkene. So let's do something more. Let's draw it out as well. Okay, and there's multiple possibilities. But I'm going to just put the double bond in the first one. 1, 2, 3, 4, and 5. There we go. Let's draw it out. Let's get some practice in there. Practice is always good. 1, 2, 3, and there's a 4th carbon over there. And 1, 2, 3, 4. Right, are we all clear? So let's go. Number closest to the double bond, 1, 2, 3, 4, and 5. Okay. 5 carbons is pent, P-E-N-T. There's a double bond involved, so it's got to be E-N-E, and we've placed it on the first carbon, which is pent 1-ene, or just pentene. Right? Okay, let's look at the next one. This one over here, let's draw that one out. CH3, let's not write it out again. There's a carbon, it's bonded to another carbon, which is bonded to another carbon, which is bonded to a final carbon over there. Now, here you can also tell where the double bond is, because there's 3 hydrogens, right? And then there's 1 hydrogen on this one, and there's 1 on this one, which has got 1, 2, 3, right? And then this one's got 3. So you can imagine where the double bond must be. The double bond must be in the middle, because now that's the only way we'd have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4 on this side. There we go. Right. Let's name it. Not yellow, but red. Closest to the double bond, 1, 2, 3, and 4. So it's going to be 1, 2, 3, 4 is bute. And there's a double bond involved, so it's ene. And that double bond is on the second carbon, so it's bute 2-ene. Now remember, bute 2-ene, bute 1-ene, bute... There's no 3-ene because you'd be numbering from the other side. Those are structural isomers of one another. If you've got butene, and you just want an isomer of it, you can just remove the double bond. And of course there are others as well. Okay. So here's the next one. This one's been drawn out for us already. We got to number it closest to the double bond, so let's just get the blue pen going there. That's going to be 1, that's going to be 2, that's going to be 3, and that's going to be 4. And 1, 2, 3, 4 carbons is but, B-U-T. Double bonds between the carbons is E-N-E. But in mud, how many double bonds are there? There's 2, so we got to put di in front of it, which indicates that there's 2 of that. And then also we've got to say where they are. They're on the first and the second carbon. So but dash 1 comma 2 dash diene. In fact, let's just write that a little bit neater. I'll write it over here. But dash 1 comma 2 dash diene. That's the name. Let's erase that. Right, and so that concludes our part on the alkenes, and then finally let's take a brief look at some of their properties and uses. Right, so one of the things that is important to note is that our alkenes are more reactive because they are unsaturated compounds. In other words, they contain at least one double bond, right? Yeah, there are compounds that have 4 or less carbon atoms. Exactly as with the alkanes, the compounds that have less than 4 carbon atoms are gases at room temperature, while those with 5 or more carbon atoms are actually liquids. Now, alkenes undergo addition reactions, and we'll cover this in a very special section while we do reactions of the different molecules, because they are unsaturated. Okay, and you can read up a little bit about this to just get some background. But I do promise you that we will cover that in a video in due course. Okay.